Hey, welcome to the greenhouse. I'm Alex. Let's talk about the greenhouse effect. A greenhouse like this one is warmed by the sun. The sunlight shines through the plexiglass roof and walls, and it warms up the interior of the greenhouse. Sunlight is mostly in the visible part of the spectrum. Energy or light is classified by its wavelength. So visible light has pretty short wavelengths. Other kinds of energy have different wavelengths. Ultraviolet is super short, infrared is pretty long, up to about 1 millimeter. These different kinds of energy behave differently when they interact with things in their environment. So the visible light passes right through the plexiglass. And that's why you can see me if I shut the door. You're looking at the visible light that's reflecting off my body and passing right through the plexi. Now that visible energy from the sun comes through the plexi, it warms up the objects in the interior, and then they're radiating energy too. But because everything here has a much lower temperature than the surface of the sun, it radiates at much longer wavelengths. Everything here is radiating in the infrared. One of the reasons that the greenhouse stays warm is because the plexi absorbs the outgoing infrared. So the visible sunlight comes through, warms up the interior, and then the re-radiated infrared is absorbed by these walls. Now, I'm radiating energy in the infrared as well, but our eyes are tuned to see visible light. What if we could see in the infrared? Would we see all of us glowing? Yeah, let's take a look at that. If we have an infrared camera, we can observe the world in both visible and infrared light. Here's an IR camera that plugs right into a cell phone. So let's hook this up and take a look. Okay, now let's switch to infrared. This image is color-coded so that blues and purples indicate cooler objects, and orange, yellow, and even white indicate much warmer objects. Notice that my face is really warm, and so is everything else in the greenhouse. Now, let's close the door. Whoa, where did everything go? Let's do that again. The infrared energy is blocked by the door. It's absorbed by the plexiglass, and so it's going to take much longer for that IR eventually to escape from this greenhouse. Now, when we talk about the greenhouse effect in the context of global climate, this is what we mean. Most gases in the atmosphere allow visible light to pass through. The light's absorbed by the Earth's surface, and then it's re-radiated at long infrared wavelengths. Other gases in the atmosphere absorb this infrared energy, just like the glass in the greenhouse. Carbon dioxide and methane are both infrared absorbers, and in fact we call them greenhouse gases. They absorb the outgoing infrared energy radiated by the Earth, and they keep the atmosphere warm. A small amount of greenhouse gases is good for us. It keeps the Earth warm enough for living things to thrive. But too much greenhouse gas warms the atmosphere more than our ecosystems and human communities can tolerate, and that begins to cause problems. And one of the reasons that these problems can be challenging to understand is because we can't see them. But fortunately, we can use some cool tools like our infrared camera to visualize the invisible and to understand it better. How cool is that?